Great apes, or hominids, are a taxonomic family of primates that includes 8 extant species in 4 genera. Pongo, the Bornean, Sumatran, and Tapanuli orangutan; gorilla, the eastern and western gorilla; Pan, the common chimpanzee and the bonobo; and Homo, which includes modern humans and our extinct relatives, e.g., the Neanderthal, a subspecies of archaic humans who lived in Eurasia during at least 430,000 to 38,000 years ago, and ancestors such as Homo erectus. Homo erectus, or its immediate Australopithecine-derived ancestors, are thought to have first dispersed out of Africa and into Eurasia shortly after 2 million years ago, also known as Out of Africa 1. Later waves of migration out of Africa may have occurred around 1.4 million years ago, early Acheulean industries, and around 0.8 million years ago, cleaver-producing Acheulean groups. Anatomically modern Homo sapiens most likely developed in the Horn of Africa between 300,000 and 200,000 years ago. There were several out-of-Africa dispersals of modern humans, possibly beginning as early as 270,000 years ago, and definitely from 130,000 to 115,000 years ago via northern Africa. A notable modern human presence first appeared during the Middle Pleistocene in Africa and started to establish continuous, permanent populations in Eurasia and Australasia from 120,000 BC and 63,000 BC, respectively, while an early offshoot settled the Near East and Europe less than 55,000 years ago, and the Americas from 22,000 BC. The most significant recent migrational wave took place about 70,000 years ago via the so-called southern route, spreading rapidly along the coast of Asia and reaching Australia by around 65,000 to 50,000 years ago. The Toba supereruption was a supervolcanic eruption that occurred about 75,000 years ago, according to potassium-argon dating, at the site of present-day Lake Toba in Sumatra, Indonesia. This eruption was the last and largest of 4 eruptions of Toba during the Quaternary period from 2.588 million years ago to the present, and it is also recognized for its diagnostic horizon of ashfall, the youngest Toba tuff, YTT. It had an estimated volcanic explosivity index of 8, the highest rating of any known eruption on Earth. The most common dense rock equivalent, DRE, estimate is 2,800 kilometers cubed, about 7 times 10 to the 15th kilograms of erupted magma, of which 800 kilometers cubed was deposited as ashfall. Toba's erupted mass deposited an ash layer around 15 centimeters, 5.9 inches, thick over the whole of South Asia. A blanket of volcanic ash was also deposited over the Indian Ocean, the Arabian Sea, and South China Sea. Assuming an emission of 6 billion tons of sulfur dioxide, a maximum global cooling of approximately 15 degrees Celsius may have occurred for 3 years after the eruption. Evidence from Greenland ice cores indicates a 1,000-year period of low delta O18, a measure of the ratio of stable isotopes oxygen-18 and oxygen-16, and increased dust deposition immediately following the eruption. The eruption may have kicked off this 1,000-year period of cooler temperatures, stadial, the first 2 centuries of which may also be accounted for by the persistence of the Toba stratospheric loading. The Toba supereruption deposited a microscopic layer of glassy volcanic ash sediments in Lake Malawi, an East African Great Lake located between modern Malawi, Mozambique, and Tanzania, but nevertheless effected no change in fossil type there, suggesting, to some, that there was not a thermally driven overturn of the regional water column. The populations of the eastern African chimpanzee, Bornean orangutan, Central Indian macaque, cheetah, and the tiger all recovered from very low numbers around 70,000 to 55,000 years ago, indicating genetic bottlenecks in many species of mammals in the wake of the Toba eruption. Ancient stone tools in southern India were found above and below a thick layer of ash from the Toba eruption and were very similar across these layers, suggesting that the dust clouds from the eruption did not wipe out this local population. According to the genetic bottleneck theory, between 100,000 and 50,000 years ago, human populations sharply decreased to only 3,000 to 10,000 surviving individuals. It is supported by genetic evidence suggesting that today's humans are descended from a very small population of between 1,000 and 10,000 breeding pairs that existed about 70,000 years ago. The coastal route theory is primarily used to describe the initial peopling of the Arabian Peninsula, India, Southeast Asia, New Guinea, Australia, Near Oceania, coastal China, and Japan, between roughly 70,000 to 60,000 years ago. The theory proposes that early Homo sapiens, some of the bearers of mitochondrial haplogroup L3, most likely similar to the Australoid populations of today, and hence dubbed Proto-Australoids, arrived in the Arabian Peninsula about 70,000 years ago, crossing from East Africa via the Bab el-Mandeb Straits. It has been estimated that from a population of 2,000 to 5,000 individuals in Africa, only a small group, possibly as few as 150 to 1,000 people, crossed the Red Sea. The group would have traveled along the coastal route around Arabia and Persia to India relatively rapidly, within a few thousand years. From India, they would have spread to Southeast Asia, Sundaland, and Oceania, Sahul,